Okay, next topic. We have talked about parallel and perpendicular, parallel being same slope, perpendicular being opposite reciprocal slopes. We've talked about vertical lines and horizontal lines. Vertical lines have undefined slope, horizontal lines have a slope of 0. And so let's talk about some other important information on the graph. We've nailed slope to a T. We know all about slopes. Let's talk about x-intercepts and y-intercepts. So in general, to find an x-intercept, all you're going to do is go to your equation and wipe out that y variable. Plug in 0 for it, so it wipes it out. And vice versa. If we want to find the y-intercept, do the complete opposite. To get a y-intercept, we want to wipe out the x variable, so just plug in 0 for it so it wipes it out. Simple as that. So if we go up here to this example number 9, we want to find the intercepts. So the x-intercept. The rule tells me I'm going to go to that equation and I want to wipe out the y's. So I'm going to plug in a 0 for the y. So that's going to take all of that away and you get negative 2x plus 24 is equal to 0. Or solving this out, negative 2x is equal to negative 24 and x is equal to 12. So we can write it like that, or we can, in coordinate form, it would be 12, 0. Because the x value is 12, the y value is 0 because we plugged in 0 for it. So there's the x-intercept. If we want to get the y-intercept, do the opposite. We want to go in there and wipe out the x variable. So that all goes away, and negative 8y plus 24 is equal to 0. Or negative 8y is equal to negative 24. And you get a y value, by the time I divide by 8, of positive 3. And in that coordinate, this time the x was 0 because we had to wipe it out, and the y was 3. And there you go. There are 2 points. If I ever wanted to graph that, I would go over and put a dot on 12 on the x-axis, a dot of 3 on the y-axis, connect those two, and there's the graph for that equation. Okay, let's go on to example 10. Here in 10, what they want us to do is write an equation again, and they're going to give us pieces of information. We know that we cross the x-axis at negative 2, and we cross the y-axis at 3. Okay, well, we need to interpret this a little bit more. We cross the x-axis at negative 2, so that means that really the coordinate is negative 2, 0, right? And then we cross the y-axis at 3, so that's the point 0, 3. Okay, well, can I get the slope? Because we always have to have the slope, right? Yeah, we can. It's the difference in the y's, so I'm going to go left to right on those points. So 3 minus 0 over the difference in the x's. 0 minus a negative 2. So our slope is 3 over 0 plus 2, which is 2. All right, now, finally, look at this right here. I can use this really special trait. If we're going to cross the y-axis at 3, don't I know my y-intercept? Yes, I do. This right here finally is my y-intercept. I can use the shortcut. I can now use y equals mx plus b because I know my slope and I know my y-intercept. So it's just y is equal to 3/2 x plus my y-intercept, which is 3. And there is my answer, just like that. Okay, well, let's wrap up this video, part 1 of this video, and let's look at example 11, which is number 56 in the book. So if you will pause it, if you don't have your book out already, will you go ahead and pull your book out, turn to page 82, just kind of look at the problem for 2 seconds, get your eyes and your thoughts wrapped all around it, and then we'll start right back here. Okay, with number 56 in the book, it says, for wages less than the maximum taxable wage base, Social Security contributions by employees are 7.65% of their wages. So for a specific level of income, then an employee has to possibly give back in terms of taxes 7.65% of their wages. Okay, so I said X is the wages earned, which they tell us, and Y is going to be then however much they're paying towards Social Security and taxes. So part A, for this problem, part A says we want to write an equation that expresses the relationship between the wages earned, so X, and the Social Security taxes paid, Y, by an employee who earns less than the maximum taxable wage base. Okay, so Y equals, we're going to go up here, and it says if they earn in this level, then what they're paying is 7.65% of the wages. Of always means multiply in math. So we're going to go 0.0765 just converting that percentage to a decimal, and of means multiply, and wages is X, because it tells us. So the amount that's taxed, the amount of money we're paying in taxes, Y, is 0.0765X. So what this problem is really is not asking us how much is left over in our wages after we pay our taxes. It's how much of our wages is going towards tax. You know, is it if I earned $800 this month, then $23.13 or something. That's what we're trying to look for. Is how much of my $800 is going towards this, specifically the Social Security tax. So all you're going to do is take the rate and multiply it by how much money you're earning, and that tells you how much. It's kind of like in the real world. I mean, this is real world too, definitely. But think of something that's more affects you guys, because a lot of you guys maybe are, some of you, probably a lot of you have a job, but just in case you don't, think about when you go to, you want to go buy a t-shirt. You know, the t-shirt is $25.99. You're not going to pay $25.99. You have to pay tax for it. And how do you figure out how much tax you're going to pay? You take the tax rate times the ticket price, right? So we're taking the tax rate times basically your income, and that's how we're finding it out. Okay. So now for part B. So by the way, so you see how this is kind of in slope-intercept form, where we can almost say that our slope right here is the 0.0765. Or if you really wanted to write this out, you know, and put it in fraction form, it would be 0.0765 over 1. Okay? So now let's go to part B. It says for each additional dollar that your employee makes, that you're making, how much is his or her Social Security contribution increased? Okay, so for each dollar that I earn, remember, is that the X variable or is that the Y variable? Well, that's the X variable because X is the wages earned. So as this goes up by $1, then what's the change in my Social Security taxes? Let's go to this slope, how I wrote it out like this. Meaning, if this bottom number, you see how it's 1, it's representing, what this is basically saying, this is the top number is your change in your Y's, or the change in the taxes, and the bottom number is your change in your X's, which is the changes in your wages earned. So if this bottom number is 1, meaning you're going up by $1, the top number tells you how much your taxes are changing. So the taxes change, or the taxes increase by, it's really by 0.07. So if you want to round that, because obviously you can't pay 0.7076 pennies, you know. So if you want to say the taxes increase by 0.08 cents for every dollar increase in wages. Okay, and the key to that, again, is the fact that our denominator is 1. So because this is a 1, it's saying when my X values change by 1, then my Y values are changing by 0.08. So my X values was my wages change by 1, my Y values, my taxes change by 0.08. Just simple as that. Okay, so part C. Part C is what Social Security contributions will an employee who earns $65,000 required to make. So if we make $65,000, that's obviously the wages. So the taxes, which are Y, it's going to be 0.0765 times my wages, 65,000. Okay, so if we put that in our calculator real quick, and our calculator will tell us then that the amount of taxes we're paying on $65,000 of income, specifically to Social Security, is $4,972.50. Yuck, right? But that's the reality, especially when they always tell us that by the time we become adults that we're not going to have any Social Security available to us. So why are we spending almost $5,000 a year? So out of our $65,000 salary, we're only getting to keep 60 of it, at least right so far, because of the fact that we have to pay for Social Security, which we might not have in the end. Oh well, but that's a whole soapbox. It's reality. It's the case of what's going on. Okay, we're going to stop this video right here. We're going to go on to the next part of chapter 2 on the next video.